Thank you. Really fun to be here. Yeah, like you heard, I'm Kristiina. I work with data science at Handelsbanken, and I'm here with Edvin from AI Sweden to talk about a topic that concerns all of you, all of us, and maybe more than some of you realize. And that topic is money laundering. So obviously intricately linked to crime, money laundering is a key enabler for all these activities like drugs, trafficking, terrorism, illegal weapons, all these activities that are so destructive for our economy and our society. And we're going to be talking about a project that aims to develop better methods and models for combating this. And this project has been a collaboration between us at Handelsbanken, team at Swedbank, and AI Sweden. And we teamed up on this because combating money laundering is really an area where, well, there's really difficult problems to solve, but more importantly, it's an area where increased collaboration could really be a game changer. So that's what we'll talk about, and we will get into this. We've developed like a framework that takes a holistic approach to tackling this. Okay, so last year, this report from Nasdaq found that an estimated $3.1 trillion of illicit funds flowed through our financial system. So that is a staggering amount. It's very big. And for these criminals, being able to do money laundering is a key element in being able to keep these activities going. Because what we mean, of course, by money laundering is taking illicit money and making it usable again by making it appear legitimate. So very briefly, the way that this is usually done involves kind of these 3 steps, where the first one just means placing it into the system. For example, depositing it in a bank. And the second step, layering, involves creating a complex pattern of transactions that has the goal to hide the origins of the money. And then the third step, integration into the legitimate economy, being able to use it to buy things or invest or something. So that's money laundering, and what we mean by anti-money laundering is then the process of detecting and preventing this. And this is the responsibility of several different organizations, so governments, regulatory bodies, law enforcement, and financial institutions like banks. And that's what we focus on here, and we focus in particular on one thing that banks do, which is called transaction monitoring. And this involves scanning all the transactions of one's customers to find suspicious activity. And it turns out that this is really difficult to do. How difficult is actually hard to say because this information isn't really made public. But we can get an idea by just considering how are we doing with AML efforts kind of globally on the whole, everyone together. And also hard to measure, but here's one estimate from the UN, which estimated that, yeah, there's a global success rate of around 0.2%. So very low. Here it's measured as the share of seized funds out of all the laundered funds. And you can measure it in different ways, but no matter how you measure it, you will find that there is room for improvement. And that's what this project is about. So that's our problem. And like I said, we focus mainly here then on the transaction monitoring part. So let's define the machine learning problem that underlies this. We consider a graph representation where our nodes are our accounts and the edges are our transactions. And the goal is to correctly classify the nodes that take part in money laundering transactions. That's the problem to solve. Why is it so difficult then? We can divide the kind of areas of issues into these 3 main categories, where if we let this represent our global transaction network, the first issue has to do with the fact that any one bank only has access to part of the total network. So that's the part that corresponds to one's own customers. That makes it difficult to find patterns that span the whole network. And the reason it is like this is partly because of data privacy laws, but it's also because any information about the AML systems of the banks is very confidential because it can be exploited by the criminals. The second problematic area has to do with the criminals being sophisticated. So they make these very complex layering patterns, they're fast to adapt to new methods, and fast to exploit weaknesses. So for example, like here, typically we'll have the pattern span multiple banks, because that's a weakness. And the impact that this has is then that we have very complex patterns that we're looking for, and they're also evolving over time. And the third area of kind of problems has to do with our labels in our data. So we have a very imbalanced problem. We have a lot more genuine transactions than money laundering ones. But we also generally lack a ground truth of our labels. So we have false negative labels because the detection rates are low, like I mentioned. But we also have issues with the positive labels. So we have false positive labels. And this is due to poor communication between the banks and the law enforcement, where banks don't generally get confirmation from the law enforcement on the cases that they kind of flagged as suspicious, whether or not they turned out to be money laundering or not. So we're in the situation where we have these data silos, we have a difficult machine learning problem to solve to begin with, and then we have a lot of noise on top of that. And this problem, or this project, initially focused on the first part, so how can we increase collaboration? But we soon found that all these problems interconnect, and it doesn't really make sense to look at just one of them. So that's what led us to develop more of this holistic framework that looks at all of this. And I'm going to head over to Edvin now, who's going to go into that, starting with how this framework addresses each of these issues.
Yes. So let's start with the first problem, the fact that the data is divided up in data silos. And in the morning, we heard a great talk by David from Scale that introduced federated learning to you guys, but we can have a quick recap of how it works. So federated learning is a machine learning technique that enables multiple parties to collaborate and train a AI model on all data. So it works like this. We have a central server that initiates a global model. That model is sent to the banks, which train the model on their private data silos. Then the updated models is sent back to the central server, which aggregates it into a new global model. And then this continues for several communication rounds until the model has converged. So this is great, but federated learning comes with some practical considerations, especially when setting this up in banks. So at banks, you usually have a lot of security layers around the data. That makes it tricky to have the local model access that data and then send that data out to the central server for aggregation. You also have system heterogeneity, which you need custom solutions at each bank, and you might have data heterogeneity as well, which can make it tricky to train the global model and have it converge. We also need the compute power at the clients. And we also need to think about retraining strategies. So when should we retrain? Can we do this once, or do we need to do it? Should we do it when authority tells us to, or should we do it when we think that a new type of money laundering activity has entered the data? Lastly, we also need to acknowledge that these models can be attacked. Specifically, you can do reconstruction attacks, where an adversary tries to reconstruct training data. So to mitigate that even more, you can, or enhance the privacy even more, you can apply secure aggregation and differential privacy. All right. But despite these challenges, we managed to set this up, actually using FEDEN, which David talked about in the morning, that is provided by Scale-out Systems. All right, the second problem of sophisticated criminal tactics. So traditionally, we have customers and their data connected to them, and what you usually do, you do some kind of feature engineering or something like that, and then you have a model making predictions on that or classifications on that data. So these models kind of handle tabular data, but the constraint is it's very restricted by how good you do the feature engineering. So it's hard for these types of models to capture a broader context. So by instead looking at data as a graph with a graph representation, you can have the accounts as nodes and the edges as transactions. And by applying graph neural networks, we actually take into account, when we make a prediction about this one in the middle, we take into account the data from the neighboring nodes. And this hopefully can enhance the predictions and make it easier to track the flow of money that is very important in finding these layering patterns that money launderers use. All right, final problem of class imbalance and incomplete knowledge. So, as Kristiina mentioned, there's a lot of uncertainties in real data. So a way to work around this is with synthetic data, because here we actually know what's in the data and we know the ground truths. So we built agent-based simulations that can produce large transactions networks that spans across multiple banks. These blobs here are different banks. Transaction spanning and also money laundering activity spanning. So we have the red ones here, is money laundering. And yeah, this simulator has a lot of can simulate a lot of different behaviors in regular consumers and also money laundering activity. And we can fit this data and tune this data in different ways. So if you have access to real data, you can ensure that the synthetic data mirrors the real data. If we don't have access to real data, we can ensure that the synthetic data is challenging enough so that a typical monitoring system has the performance that that it should have. So in this project, we wanted to emulate Swish, which is a Swedish mobile payment system. And we created data from over 12 banks and with 100,000 accounts and 7.8 million transactions. We ensured that the synthetic data had it was challenging, so a typical monitoring system had a false positive rate of 95%. And we added different kinds of patterns. Here's a very simple one to more complex ones. And they vary a lot in size, from below 10 to above 60. And they all most of them span over several banks. And it's very unbalanced as well, so only 3% of these transactions are money laundering. All of this we packed into our holistic pipeline, so AML Gentex. So here we can actually go from creating synthetic data, tune that data, introduce noise, then some visualization, feature engineering, and also training model in isolation, which is in practice today at banks. Then evaluate that to federated learning and also comparing to a centralized setting where you collect all the data. We also looked into explainability, where one tries to explain why the models predict as they do. But what can we tell you with all this? So here we have some model evaluations. On the y-axis, we have average precision over a recall span. This is a good metric because it gives us, tells us how good we are at catching money laundering activity while operating within a accepted recall span. And the red dashed line here is a decision tree that kind of simulates a rule-based monitoring system. So that's basically what's in practice at banks today. Then we evaluated 2 models that handle tabular data and 3 models that handles graph data, so graph neural networks. And we see that two of the graph neural networks performs the best. We then looked at federated learning. So all the way to the left here, we have 1 client. This corresponds to training in isolation, which is what's in practice today at the banks. And then we increased the number of clients, so participating in the federated learning. And we see here that the graph neural networks gain a lot. One of the tabular gains some, but actually this is a small logistic regression, so the capacity of the model is probably filled by the data from the first client. Lastly, we also looked at introducing noise into the data. We see here that all models are affected. There's a negative effect on all the models, but we expected actually more of an effect. But yeah. So the takeaways from these are federated learning and utilizing the graph structure increase performance, while noise has a negative effect.
Yeah, thanks. Yeah, so we definitely had some results that indicate that these new technologies are worth pursuing for banks. It's worth to look into these. And then we had some results that we need to dig a bit deeper, some things we didn't quite expect. And that's a great example of why it's so necessary, crucial, to have this controlled setting of the synthetic data set, where we can start to probe questions like that. And that's the path that we're going to continue on moving forward. So we're really going to focus on extending the synthetic data capabilities of AML Gentex. So more types of transactions, making it even more aligned with the empirical data. And that's because having these big, high-quality data sets that can be shared is key. It's where we need to get to be able to collaborate, benchmark, and move forward. And it's crazy, but today there is a total lack of that. That doesn't really exist because of the privacy and because it's difficult to simulate this. So there's a huge need for that. And moving forward, a very big part of this will be to include more actors. And it's been really fun because we've gotten a lot of interest from other banks as well as organizations like FI. So yeah, moving forward, we can hopefully build more on this with even more partners. And yeah, with that, I want to thank everybody who's been involved from Handelsbanken, Swedbank, and AI Sweden. And I can point out that Anton from Handelsbanken and Johan from AI Sweden are also here today. So if you come across them, you can also ask them questions. Thank you.
Thank you.
Thank you so much, Kristiina and Edvin. Actually, it was, I thought, so much technical depth and at the same time strategic thinking. I wanted to ask a question, and also, sorry, thank you for shedding a light on the lack of data and the need for sharing more, although, yes, the privacy issues. I have a question regarding the fact that graph neural networks, of course, are a powerful tool here, but some might say they are still hard to interpret, and I was wondering if you are going to work to address explainability in the future, especially for decision makers inside the banks, or?
Yes, so an explainability module is part of the framework, will be developed more, and yeah, this is very important. This is part of the, in some ways, more difficult side of this, of getting it actually in place, which is not the technical side, but the kind of legal and regulatory side. So this will be a very important thing, gaining trust from regulators and law enforcement, but also within the bank, so that it can be realized in practice. Super important.
Thank you. Are there questions from the audience? I'm so sorry for stealing the first question. I just felt.
I see one there.
Microphone is coming.
Thank you for a very interesting presentation. I was curious if you got all the banks with Swish involved right now, would it be possible to implement this in reality, or are there regulatory hurdles to overcome first?
I mean, that's a great question. I mean, we don't even know quite that yet. I mean, like, there's a lot of questions that don't have an answer yet. Like, how do you like risk assess these like model weights of federated learning being intercepted, like all these possible hypothetical attacks? Yeah, there's no answer yet. More people need to get involved to look at this. More people from more than the technical area. Lots more work to be done.
Thank you.
Thank you very much. Do we have another question for Kristiina and Edvin?
Hey, thank you so much for interesting presentation. Fantastic work you are doing. I'm wondering, data silos, it's not about that each bank has only a part of the data. I mean, one laundry process can start in one bank and be finished in another bank. Do you have any techniques? How do we do that connection? So this is the one thing.
Yeah, excellent question. So federated learning in itself, like, it doesn't necessarily draw those connections across the banks. However, there are new research into federated subgraph learning, where you actually, so you use federated learning, but you acknowledge that the data is connected in this type of graphs that spans over the clients. Yeah, there's some papers on it, but there's stuff you can implement that really captures the patterns that spans across the banks. But yeah, it's new research. Talk to Johan Östman if you find him. He can tell you more.
No, Johan Östman said he went to the other track, to the parallel track.
Okay.
So, no, I'm joking. Do we have another question?
Hi, yeah, thank you very much. Super interesting stuff. I just had an idea. I have no idea if it's good, but can we blockchain regular fiat transactions in order to combat this issue?
I mean, spontaneously, probably that would break some kind of data privacy law, and also making. I mean, you would still have the problem that, like, even if you could somehow sort of share information about the network, we also can't share information about our labels, because that would reveal a lot about email practices that could be exploited by the criminals. So without, understanding the details of that idea, probably there would be some issues. But yeah, an upside of blockchain, of course, is that sort of what's going on globally is always available.
Yeah, I reckon so too. I don't know the details either, but it's an interesting topic.
Yeah.
Thank you.
We actually have time for one more question, if it's very, very short. Oh, yes, I see one hand up there. And then...
Hello, thank you for a very interesting presentation. Short question then, can you find interest or relevance in only looking at the transactions that are between banks and all the interbank transactions, if you kept them secret? Would that be an easier way to get around the regulations?
So, do you want to answer this?
Do you have any?
Yeah, I mean, you can look at at least you can look at the incoming and outgoing from your bank, but then you can't really share anything else.
Because with that you could give the banks the tools to look at the internal transactions and find the bad actors there, and so.
To me, it sounds like you're sharing too much data. If I understand your question correctly.
Okay, thank you.
Okay.
Thank you so much, and I'm thinking maybe there will be some follow-up questions for you,
Yeah,
when you get off
Just
stage.
come find us.
Yes,
If you,
absolutely.
That's great. Thank you, and please accept some flowers from us. Thank you, Kristiina. Thank you, Edvin.